Analyzing the potential for a major Nankai Trough earthquake. 1. Geological background of the Nankai Trough. The Nankai Trough lies at the convergence of the Philippine Sea Plate and the Eurasian Plate, making it one of the most seismically active regions in the world. This tectonic boundary stretches approximately 700 kilometers from southern Taiwan to southwestern Japan, running through the Ryukyu Islands. It is a classic subduction zone, where the Philippine Sea Plate is gradually being forced beneath the Eurasian Plate at a rate of 6 to 8 centimeters per year. Over time, stress builds up along the fault line, and when it reaches a critical point, it releases in the form of a powerful earthquake. Historical data suggests that this region experiences a magnitude 8+ earthquake every 100 to 150 years. The last major quakes in this area occurred in 1944 and 1946, leading scientists to predict that there is an 80% probability of an 8.5+ earthquake occurring within the next 30 years, and a fond 9.0+ event cannot be ruled out. 2. Potential scale and impact of a future earthquake. A magnitude 9+ earthquake in the Nankai Trough would have catastrophic consequences for East Asia. Based on advanced modeling and seismic simulations, the estimated destruction radius could cover hundreds of thousands of square kilometers, impacting major population centers in southeastern China, Guangdong, Fujian, Zhejiang, all of Taiwan, northern Philippines, the Ryukyu Islands, Kyushu, and parts of Shikoku in Japan. 1. Direct seismic damage. If an earthquake of this scale were to occur near the eastern edge of the Nankai Trough, closer to Taiwan and the Philippines, the shaking would be intense enough to cause widespread destruction in coastal cities. Buildings, bridges, highways, and ports would suffer extreme damage. Many coastal urban centers in China and Taiwan and Japan are built on soft sediment layers, increasing the likelihood of soil liquefaction, which could cause parts of these cities to sink by 1 to 2 meters. Drawing from the 2011 Tōhoku earthquake, we can estimate that a 9+ event in the Nankai Trough could shift the Earth's crust by 30 to 50 meters, with strong shaking lasting 5 to 10 minutes and followed by hundreds of aftershocks. 2. Tsunami threat. Tsunamis are often the deadliest consequence of a 9+ earthquake. Nearly every recorded quake of this magnitude has triggered massive, high-energy waves. Estimated tsunami height 20 to 30 meters. Time to reach China's southeastern coast 2 to 3 hours. Time to reach Japan and Korea 4 to 5 hours. Tsunami impact zone from China's east coast to all Pacific coastal nations. If the earthquake occurs at a shallow depth, less than 30 kilometers, the resulting tsunami could rival the 2004 Indian Ocean tsunami, which devastated multiple countries. Coastal cities such as Hong Kong, Xiamen, Taipei, and Manila would be at extreme risk, potentially facing waves up to 30 meters high, sweeping away entire neighborhoods. By comparison, the 2004 tsunami in Indonesia reached 30 meters in height and killed over 230,000 people. A similar disaster in the Nankai Trough region could put millions of lives at risk. 3. Secondary disasters. In addition to the initial quake and tsunami, a major Nankai Trough earthquake could trigger volcanic eruptions. Japan's Sakurajima volcano and the Taal volcano in the Philippines are active and could be destabilized by the shaking. Nuclear accidents. Nuclear power plants in Fujian, Guangdong, Taiwan, and Kyushu could suffer damage, leading to a Fukushima-style radiation leak. Landslides and infrastructure collapse. The mountainous terrain in Fujian, Taiwan, and the Ryukyu Islands is highly susceptible to landslides, which could bury roads, railways, and towns. 3. Historical precedents. Scientists predict that a Nankai Trough earthquake would follow patterns seen in past 9+ megaquakes, including 2011 Tōhoku Earthquake 9.0, over 15,000 deaths, tsunami waves up to 40 meters, Fukushima nuclear disaster, 2004 Indian Ocean earthquake 9.1 to 9.3, over 230,000 deaths, tsunami affecting 14 countries, waves up to 30 meters. 1960 Chile earthquake 9.5, over 2 million people displaced, triggered tsunamis across the Pacific. The geological similarities between these disaster zones and the Nankai Trough strongly suggest that a major earthquake is inevitable within the coming decades. 4. Estimated timeline for the next earthquake. The last major Nankai Trough quakes occurred in 1944 and 1946. Given the historical recurrence interval of 100 to 150 years, current estimates suggest 80% probability of an 8.0 plus earthquake within the next 30 years, 40 to 50% probability of a 9.0 plus earthquake within the next 50 years. Japan's government response and ongoing earthquake warnings. Following the magnitude 7.1 earthquake in Hyūga-nada on August 8, 2024, the Japan Meteorological Agency, JMA, took an unprecedented step by issuing its first ever Nankai Trough Earthquake Temporary Information. This advisory warned that the tremor could be a precursor to a much larger megaquake along the Nankai Trough, urging the public and local governments to stay on high alert. Escalation of government alerts. Over the following weeks and months, the Japanese government ramped up its earthquake warnings, citing the possibility that the August 8th quake had increased stress along the subduction zone. The Cabinet Office, the Earthquake Research Committee, ERC, and JMA collaborated to issue a series of public advisories emphasizing that 1. Probability of a larger earthquake had increased. Government scientists suggested that the Hyūga-nada earthquake might have triggered stress redistribution along the Nankai subduction zone. Studies of past seismic sequences showed that similar, moderate earthquakes had preceded major Nankai earthquakes by months or years. Number 2. Coastal regions should prepare for a tsunami. Miyazaki, Kochi, Tokushima, Wakayama, and Shizuoka prefectures were placed on heightened tsunami alert. Evacuation drills were ordered in all coastal communities, and emergency shelters were inspected to ensure readiness. 3. Citizens should remain prepared for sudden, large-scale seismic activity. The government advised households to stockpile emergency supplies for at least 1 week, including food, water, flashlights, and medical kits. All schools, hospitals, and businesses in high-risk areas were instructed to review their disaster response protocols. Public reaction: fear, skepticism, and earthquake fatigue. As weeks turned into months without a larger earthquake, public opinion became increasingly divided. Some residents took the warning seriously, reinforcing their homes, relocating from coastal areas, and actively participating in evacuation drills. Others grew frustrated with the constant alerts, feeling that the government was fueling unnecessary panic. The media coined the term Nankai Trough anxiety, describing the psychological stress caused by continuous reminders of a looming disaster. A segment of the population began to question whether Japan was experiencing a boy who cried wolf scenario, where repeated warnings might lead people to ignore future alerts. Simulated emergency scenarios. In response to growing public concern, the Japanese government conducted full-scale earthquake and tsunami simulations under the assumption that a magnitude 9.0 plus event could strike the Nankai Trough at any moment. Over 1.5 million residents participated in evacuation drills, including those in Tokyo, Osaka, Nagoya, and coastal prefectures. High-speed rail operators, including Shinkansen lines, tested automatic braking systems to prepare for potential seismic shutdowns. Nuclear power plants along the Pacific coast underwent stress tests to evaluate whether they could withstand a megaquake similar to the 2011 Fukushima disaster. Scientific uncertainty: why hasn't the big one happened yet? Despite the ongoing alerts, no major earthquake has yet occurred. This has led some experts to reassess their models. The August 8th earthquake may have released only minor stress, delaying the inevitable rupture. The fault may still be locked, accumulating energy for a more violent event in the coming decades. There may be complex interactions between different segments of the subduction zone, making precise predictions extremely difficult. In other words, a megaquake in this region is highly likely within our lifetime, making preparation crucial. 5. Mitigation and preparedness strategies. To reduce the impact of a future Nankai Trough earthquake, governments and communities must take proactive measures. 1. Enhanced seismic monitoring. Deploy satellite-based sensors and underwater seismometers to track fault movement. Improve tsunami early warning systems to provide residents with critical evacuation time. 2. Strengthening infrastructure. Construct earthquake-resistant buildings that can withstand 9.0 plus magnitude shaking. Reinforce key infrastructure like bridges, nuclear plants, and emergency shelters. Emergency preparedness and evacuation plans. Establish designated tsunami evacuation zones in all coastal cities. Conduct regular public drills to educate people on earthquake survival strategies. Stockpile emergency supplies such as food, water, and medical kits in at-risk areas. Conclusion. A Nankai Trough 9.0 plus earthquake is not a matter of if, but when. Scientists estimate a high likelihood of such an event occurring within the next 50 years. Given the dense population centers along the Pacific Rim, this earthquake could rival the deadliest natural disasters in modern history. While we cannot prevent earthquakes, we can mitigate their impact through scientific advancements, engineering innovations, and effective emergency planning. The key to surviving the next major quake lies in proactive preparedness, ensuring that millions of lives are safeguarded when disaster inevitably strikes.